Thanks for joining. Day number 16. Today, I'm going to cover just one part, 5.1. So if someone will miss the class, he can watch the recording and he can understand those things. And let me walk you through the topics that we have in section number 5. You can see section number 5, infrastructure and automation, weightage is 20%. And let's see the topic. So topics we have to understand the model-driven programming, compare controller to device level management, describe PyATS or Cisco modeling, lab, CI/CD, infrastructure as a code. Like these concepts, we have to understand the Terraform, the Cisco NSOs, Ansible playbook, the Bash script, different type of script, different types of modeling languages, and all. Like, these are the topics we have. So starting from 5.1 up to, you can see that we have 5.14, total 14 subsections we have, and this is very much like summarization of what is networking automation we have in Cisco. What are the different type of strategies we can go and use to automate the network? Most precisely, infrastructure as a code, IAC. Actually, infrastructure as a code. That's the thing. Actually, nowadays companies, they want to do achieve that. Like everything they want to solve, all the operations and maintenance and deployments, everything with help of coding. So that term is becoming infrastructure as a code, but the programming language used for infra as a code is nothing but the Terraform. Terraform is a language which can provide infra as a code both on-prem and cloud deployments we can do with Terraform. We'll see that. Today I'm going to cover just one topic, that is describe the value of model-driven programming for infrastructure automation. Right. So describe the value of model-driven programming. Just simple one topic today I'm going to cover. What's the use? Let's try to understand the use of this. What is model-driven programming? You have some model defined, you have some well-defined architecture, and with that well-defined architecture, how you can do the programming. So that's the idea related to model-driven programming. And there are examples related to model-driven programming that we will see. So model-driven programmability offers significant value for infrastructure automation by providing a structured approach to define and manage network configuration, right? You have some model, some structure that you can follow and do the automation for a network. Like for example, Yang model. That is one of the modeling language. You can follow the Yang model, and then with the Yang model, you can do the automation, network automation. So here you can see that we have some benefits like abstraction and simplification. Abstraction and simplification means that you have one defined model, and with that defined model, you can go and build the codes, right? So you have this model-driven programming abstract, like complex network configuration into high-level models. That's the key actually. You have things defined, and that with the thing, you can go and do the, you have the model, and according to that model, you can go and do the automation. It simplifies the configuration task by providing a standardized representation of network elements, protocols, and services, right? So you will see that it has some, some label of abstraction, some label of things. By that, it can go and provide the automation. We'll see that. Then consistency and standardization. Using models ensure consistent configuration across device and environment. you know, all these points, when you see this in action, you'll understand that how it is doing the abstraction and simplification, consistency and standardization, automation and efficiency, scalability and flexibility, visibility and control, versioning compliances, collaboration and DevOps integrations, all these things. You can see point number 1, 2, 3, 4, 5, 6, 7. All these things you will achieve, right? All these things you will achieve. So these things are there that we can achieve with help of the modeling language. Means we have some best practice. You can think like you have some ITIL type of process. What this ITIL is doing? ITIL is a process, or it's a defined method. It's a best practices, you can say, uh, that companies can use and define their process. So that is nothing but process related best practices. Likewise, you have some model, you have some standard, and you can follow those standard, and you can do some standard automations and all, right? So you will understand these things via example. And in this standard modeling, you have abstraction, you have consistency, you have automation, scalability, flexibility, version, compliances, collaboration, all those things you have. Now what I'm going to show you here, that let's try to understand this model of language, and with this model of language, how you can go and automate things. That's our goal. That okay, I have some topology, and in that topology you can see that we have some topology here, that we have router 1, 2, 3, and they are connected with switch 1, 2, and 3, right? So you have some topology, and with this topology, how you can go and you have this configuration. See, you have the topology, and with this topology, if you have to configure the router, so what you will do? I'll go to router 1, configure the interface, provide some IP addresses, do some description. I can go to switch 1, configure the interface. If it is a switch port. Otherwise, if it is a L3 interface, then we can go and provide some IP addresses, and like that. So switch to switch connectivity, some trunk configuration, like it's a L2 connectivity or L2 configuration. And switch to router, maybe we have L3 type of configuration, but this is my overall architecture, where R1 may be connected with ISP, R2 and R3 may be connected with some core switch. Likewise, we have the topology, right? Network topology. Now we have option, we can go and configure it via CLI. We can go and log into devices one by one, and configure it. That is our CLI approach, like normal approach. But now, if this is the topology you have, and you want to create some standard, then how you will configure it? You have to create some standard, and according to that standard, how you can go and configure it, that we can go and discuss here with this modeling. So that means we have some model approach, we have some modular approach that we can go and use. Let's see how we can do that. So first of all, what I have done in this, that I have shown some, you can see the configuration here. You can see the interface and IP address, interface and IP address, and you can see some IP router statements. You can see the switch. Here you have the L2 configuration. Switch, you can see some L2 configuration. Over the VLAN, you can see the IP address configured. Interface, you can see the L2 configuration. L2 configuration. Over the VLAN, you can see some IP configuration. over the interface, you can see that L2 configuration, right? So you have mix of L2 and L3 configuration and what type of configuration you want to do. Now this thing, we can go and use some sort of modeling language. So if you see the agenda, I told you that today I'm going to cover only one topic. So if you see the agenda that describe the value of model driven programming. So what I have done, I have clubbed this 5.1 with this 5.11, interpret basic Yang model, right? This and this, you can club and you can understand these topics. So let's try to understand. This is the modeling language we have, and with this modeling language, we can understand this. So what is Yang? Yang is yet another next generation language. Is a data modeling language used to model configuration and state data manipulation by network configuring protocols such as NETCONF, RESTCONF, and other networking management protocols. Yang models define the structure and constraint of network data. So that means you have some model, you have some structure, and that structure, obviously it will go and use some sort of protocols, right? So it can go and use protocol like NetConf, it can use some RESTConf or any other networking management protocols. Yang model defines the structure and contains the network data which can be used. You will see that it has the model and that can be used to generate configuration, retrieve the operation data. Like with this model, you can go and do some sort of uh, configuration management, backup, some operational task, those sort of things we can do. So we can go and define the, you can go and use the well-defined structure architecture, and according to that, you can go and use this structure in different use cases. Right. So I have some structure and I can utilize it in different use cases, sometimes configuration, sometimes retrieving the operation data and all those things. Right. So let's understand this. The module, so it has its own component. You can see the module, the namespace, the prefixes, container, leaf, list, type, module. What is this module? Obviously, some module. For example, interface configuration. So I can go to this interface, and in this interface, I have IP address, description, some other configuration. So within the module, I can go and configure the items, right? So here you'll see top level module. A Yang module is a top level structure and define the namespace and data structure. It will define the namespace and data structure. Actually, I understand I have one diagram. I should have something. Okay, it is not in there, but you will understand that module is nothing but the declaration. For example, interface. So here you can see the module, right? This is defined as a module, and in this module we have example interface. So this is my module where I am defining some namespace. So you can see, and that's why I created this document, so you'll understand it. So module is top level structure, define the namespace and data structure. Namespace and data structure. It contains namespace, prefix, import statement, various data definition. So here you will see in the example, it contains, so module contains namespace, prefix, import, and various type of data structure. This is your block module define, right? That means you are defining something, and in that module you can go and create the namespace, prefix, import statements, etc. After that, namespace. Namespace is nothing but the placeholder. The namespace uniquely identifies the module to prevent the naming conflict. So it has the namespace. It is defined to provide if you have any conflict related to naming. So namespace will provide the uniqueness. It is there to provide the unique identification to the modules, right? So that's the namespace, and then you will see different type of terms like prefix, container, leaf, list, type, and all these has the significance. Prefix is a short string that is used to reference the module namespace in the instance document. So here you will see that you have the prefix as well. If this is a short form defining interface, right? IF for if, like that you have the prefix definition, short string that is used to reference the module namespace. Container, this is important. A container groups related nodes together. Like it can contain leaf node, list, other containers. Right. So container means something it has. Right. So leaf nodes, list, other containers. You can see container, list, leaf, and within container interface itself, you can see that we have list, key value type thing. You can see leaf name type is string, enable is boolean true or false. So like this is the interface name. You can see interface name, and this is the state of the interface is up or down, like that. But this is not yet. Yes, it's not completed. Then you can see container IPv4. So leaf address, type address, net mask, and net mask. Right. So this is something that we are defining the interface. Over that interface, we can go and define the name of the interface. Then the status of the interface is up or down, like shut, no shut. Then the IPv4 address for that interface and the net mask. This is something that writing the configuration like this, interface gigi 00, no shut, IP address, something like that. Yeah. So this is the end goal. We want to achieve this state configuration. But this is the defined template that we can use. This is the standard template, and this template can be used for any of the interface. This is one state, one interface configuration. This is the fixed configuration, but this is defined as a model, and it can be used to configure any interface with any IP address with this model. Because here we are not defining what is gig 00 or a state shut no shut or IP addresses, subnet mask, etc. Because here everything is can be worked as a variable, right? So this is one of the model that you have. Then the same thing I have explained here, that what is the meaning of module, the namespace, import a statement. We can import something from another module, right? And that Yang module that we can import, actually Yang module is defined by IETF body. So that is IETF interfaces, but different companies, they may have their own style of modules defined. Container interfaces, right? So you know that what is container, what is a list. List is something like list interface key. Define a list of interfaces. Each entry in the list is uniquely identified by the name. Leaf node. The nested container means container within container we can have. Right? Understanding this, if you have any problem, just let me know.
Question, Ranesh.
Yep.
So the young model, once you have one like the one you show, how do you call it to your script? Like, or you need to create like an XML, right? For that,
Yes,
or
I'm going to show
okay,
that today. Today I will show you after few slides.
okay.
Okay. So you can understand the model, that the structure, right? Now how we can go and use it within the program, right? So let's see. And that's why I told you that today I'm going to cover only one topic. This is the only one topic I'm covering today. That's it. So let's see this Yang in action. So here you'll see that we have one lab scenario that let's try to understand. Earlier I have shown you one diagram, router, switch, router, switch, router, switch, right? Connected, we have connection, right? Router to switch connection and all. So we are going to configure this particular lab with the Yang model. So that means I will go to the router and try to configure the interfaces. We'll go to the switch, try to configure it as a L3 and here L2 configuration. So let's see. Here we are, router 1. You can see the module defined as a router, namespace, prefix. This is the format for the Yang module. And then we can go and import the IETF interfaces as if. So this is the module for router I am defining related to interface, name of the router and interface. Now here you will see the container. In the container, now we are defining container gigi00. Type is this. It is referring this type, because we are importing from IETF type. So it will refer this particular type. Then argument, the interface, defining the interface like this, like, interface maybe Ethernet, CSMS, CD, etc. So this is the reference for the interface. Within the interface, when type is this, so here you can see the condition. If this is the condition, I will go and put the IP address, IPv4 address and subnet mask, right? So defining a particular interface for router number 1 gigi00 and importing the package, the module, this particular package, importing from here, from the module, and then we are defining the interface for router number 1. Then for switch number 1, you will see the switch number 1, the same way we have the namespace, prefix and import a statement. For switch number 1, the router 1 is connected with switch 1. For example, router 100, switch 1 is 0/1. So switch 1, 01 and 02, because you will see the diagram. Just assume that you have two interfaces. So one interface is going to this direction, one interface is going to this direction. Maybe here you have trunk and some VLAN, or maybe some access VLAN. Here you have some L3 configuration. Okay, so you can see here that router 1, you know that switch 1, switch 1, 01, interface 02 interface, just the reference. Then type the leaf VLAN 10 and referring. So for this is interface VLAN 10. So this is L3 interface. We don't know these interfaces. We may have L2 or L3, but these three interfaces, this is physical interface, this is physical interface, this is SVI, switch virtual interfaces. Everywhere we are referring this interface from here because we are importing from IETF interfaces. Now, for all these three interfaces, if they are L3 interfaces, then argument interface, then the condition. If the condition is this, container IP, IPv4 address and the net mask, IP and net mask. Okay, very much like same. So that means that if you are able to understand the configuration or the building block for one of the router or switch L3 interface, very much same way you can go and build the other devices as well. Now if you go to switch 2, same thing. You can see 0 1 0 2, this is connected with router, this is connected with other switch, and this is, and switch number 2 we have two SVI 10, SVI 20. So we have 10 and 20 which is referring from here or referred from here, and then same way we have the IPv4 addresses and subnet mask. Switch number 3, same way, we have the namespace, we have the prefix, import statement, container, then you can see this Ethernet, and then you can see the SVI, right? Switch virtual interface, SVI. Now you can see that we have the interface, and in this interface, we have the IP address and the subnet mask. IP address and the subnet mask. So likewise, you can see that this is the modeling language. Now how we can go and configure the devices, I am going to show you in the upcoming slides. But till this point, if you have any doubt, please feel free to ask.
Oh, no, no question for me.
Okay, so now this is the model, very much like structure and model. Only thing we have done, we have given the exact interface name here. Now how we can go and do the data encoding? Remember, in API, we have something called payload. When you are dealing with RESTful APIs, then you are using different type of methods like put, post. So at that time, we are using the JSON data encoder. This is nothing but what is data encoding method as a payload. If you want to configure something, you need something to configure it, obviously JSON file or maybe XML file, etc. Here also in these configurations also you need some payload. You need some IP address, the exact value that can go and fit into these models. So let's see that how we can go and provide the payload. So these Yang scripts define the configuration of routers and switches, etc. And then we have the namespace, prefix, import statements, and all those variables. Here I'm going to show you the XML payload. Let's see. Now you see router 1 payload. Right, payload. So router 1 IP subnet. Now it's very, these XML formats are always very lengthy. But anyways, we have this option only. So router number 1, gig 00 and 01. 00 and 01. I should define 01 as well in router number 1 if I'm using here as a payload. You can see the switch. The switch number 1, F01, and then F02. I should give the IPs here, IP and subnet. I have leave this as a blank because in my lab, for example, I don't want to configure other interfaces. So they are blank. They don't have any value. If you want, you can go and give some values here. So address, subnet, net mask, etc. These values you can give, but this is very much the format, how the payload will fit into the Yang model. Next, let's see. Switch to only I want to configure VLAN 10. So I have VLAN 10 IP. If I have VLAN 20, so so VLAN 10 and VLAN 20 IP I have. I'm not configuring F0/1. In switch number 3, I'm only configuring VLAN 20. So I put the payload related to VLAN 20. Likewise, you can go and put, if you have VLAN 10, if you have other interfaces, you can provide the payload. Now these XML payload represent the configuration specified in the perspective of or respective of Yang model. So that means you have well-defined structure. In that structure, what modules you need, what are the configuration you need, you can define as a structure. And then with help of XML, you can utilize the payload like this, right? And then you can configure it. Now, next question you may ask that how I can go and connect this model with this payload, right? So for that, we can go and use the Python script. So we can have the Python script, and with help of Python script, these models and XML can be integrated, right? So here you will see that you can go and use this, what is that, DevNet lab. In DevNet lab itself, I have done this, and we have that as an example as well. So let me quickly pull the example as well parallelly so you can understand that part. Let me see. Last time we were doing some Docker. Okay. Let me open this in the other window and pull here. Our CCNA DevNet. Hmm, Okay. So before going there in the examples, let me quickly show you this. So this is the, you can see the Python script, some netcon push, and here you will see that this is not the young model. This is normal router configuration with netconf. Let me open all the configurations and everything. Just to showcase you. Okay. So you can see here that I'm using this XML, right? So I have in the same folder, I have XML file. So I have XML file for router 1, switch 2, switch 3, etc., etc. Switch number 2, switch number 3. These are what? These are the encoders, right? These are the data encoders. That means that these configuration you want. Tomorrow, if you have to configure F0/1, then what you need to do, you can go and put values here in between this. So IP and subnet. And your F01, F02, F03 will be ready. So you have the XML file. You can see you have the XML file. I have created MD file. You have the XML file. You have the XML file, right? But you need some script. You need some script like this to call the XML file and push it. Right? So let's move on. Let's go further and try to understand a little bit more about this. You have some NC client. You can see this in Python variable. You can use the NC client. NC client is nothing but the package for NetConf, right? NetConf Yang client. So you need this NetConf client to set up your Python. So here you can see step by step I have created this document. Install the NC client, create a Yang model configuration in XML, right? So using this model, so we have this model, right? With this model, we have created the XML model related to that, which is following the same sort of Yang model. Again, this is one example. We have other examples as well. And then, so here you can see that is step number 2. With the Yang model, we are preparing the XML format, the same type of model. Then we are creating one script. We are creating one script to push this model to the device. So for that, we are using port 830. Port 830, why we are using it? What's the significance of this port? This is the NETCONF port, right? Port 830. It will SSH to the device with this port and configure it. So we have the device parameter we are creating with help of. So we have some abstract with help of Yang model structure. We are creating the XML encode or XML payload, right? And then we are pushing to the device. Once you push to the device, you can go and run this and configure it. Any question you have?
No, no, it's more clear now. Now that
Clear?
I see the code. Yeah.
Alright, so that's the significance we have with the Yang model. You have well-defined structure, but we have to go and create such type of payload that will be used within the Python programming, and then it will work. Now, these models that we have actually, these models that we have, it should be natively supported within the device. So you have to go to the device and you have to enable netconf yang, and then only we can go and configure it. So that means within the device itself, we have to go and run one command and even enable the SSH as well. So there are prerequisite for such type of task that you should have SSH enabled, and you can go to conf team like global configuration and you can go and enable the netconf yang, right? So like that you can do, and then you can go and play around with this task and all. Easy. If you can go and book the DevNet lab, these are the tested example. It will work. So it will go to this particular interface and it will configure the interface with this router one. Okay. Thanks for joining everyone. Today, day number 17. Most of these topics that I'm going to cover, you know those things. Simply, I have to show you that this is covered in a syllabus, but these things you already know and you are using in your day-to-day life activity. Let's see. Starting from 5.2, I will try to complete 5.3, 4, 5, and if it is something related to some other topics that I want to complete as a project, so I will show you that, okay, within the project, we can discuss that part. So let's start this 5.2. You can see clearly, you can see the name. Compare controller level and device level management. Now, before going to this, what is controller level and device level management? Can you tell me that? Yeah, while I'm drawing, you can tell me that what will be the controller level or device level management.
Like the SD-WAN controller or DNA controller and device
100%, yeah,
individual.
100% right. Yeah. So what it is telling here is this, that you can log into device, right? Individual device, like you can SSH, Telnet, SNMP, other things, and you can manage, right? So that is nothing but device level management. You can log into individual devices and you can manage, or you can, you have some controller, maybe SNMP server, your SolarWind, your other type of management servers that you can go and connect with the devices. That means you are using some sort of SNMP, and then you have SNMP server, for example, SolarWind or something. You are connecting to them and you are managing their devices, right? Or maybe that you told that, okay, I have controller, SD-WAN controller. In SD-WAN we have vManage, and from vManage I can go and manage the devices, like, you know, Device management. Device management means iOS upgrade, the interface status, the event logs, logging monitoring, etc., etc. So those are under the management of device management, like, operational managements and all that we can do from the controller. So individually we can do from devices as well, but that is time consuming. That is not a standard way to do that. So later on we'll move to the controller based management. And that's the same thing you can see here. Controller based means centralized, single controller, push from controller, simplified the administration, ensure the consistency. Device level means decentralized, individual device interfaces, configure each devices separately, complex to manage because of overhead, challenging in ensuring consistency of across the devices. So yes, this is very much like centralized versus decentralized system, right? So that's a topic that is, this is CCNA level topics. Some topics are very easy. And then I have done some comparison, like in terms of scalability, network expansion, visibility, troubleshooting, security policy, security update, operational cost. This is important. Reduces cost by simplifying management, higher due to increased time and effort. Capital cost, potential higher initial cost. Initially it will be higher because you need to purchase extra piece of software, the extra licenses for controllers and all. But later on, this will become down. Lower initial cost, but higher over the time due to management overhead. Right, so this is actually better solution if we are going for controller level management rather than device level management. And now we have controller level management in not only like Cisco SD-WAN or Cisco DNA, but firewall. Firewall also in Cisco we have FMC. From that you can go and manage the FTDs. The Wi-Fi networks where we have WLC controllers and then we have the APs. So from WLC controllers we can go and manage the access points, right? So those things are there. Any questions so far? You have any question? Easy, right? It's straightforward. Let's move to next topic. I told you that topics will be easy only. Now the next topic we have, they are not expecting that we should go and log into CML. CML is very much like Cisco GNS3, where you can go and perform the lab, but this is Cisco modeling lab, where you have the iOS XE, XR, ASA firewalls and other devices. But that is paid one. You need to go and purchase the license for this and buy it. So let's see. Describe the use and roles of network simulations and test tools. So you can go and use the test tool, CML PyATS. One of the best test tool we have that is very much open source is EVNG. So instead of using CML, we can use EVNG. Like you have your company infra, like in your infra you may have 4 core routers, 6 core switches and then access switches. So all those network, whatever network we have that is working as a core network, we can simulate that same network over EVNG. So that means that I have the corporate network which is running one same type of replica I can create over EVNG as well, and then I can go and do the automation for those devices. So that will be your test environment, that same type of network, IPs, interfaces you are using in your EVNG lab as well. And then you can go and do all sort of testing, right? The other option we have PyATS. What is this PyATS? So let me go and show you this. Cisco PyATS network test and automation solution. This is something like automation, troubleshooting solution, etc. PyATS is a test bed profile, you can see it's PyATS architecture, and you can go and book these things over Cisco DevNet portal as well, developer.cisco.com, where you will get this PyATS docs and Genie and all those things. Okay, so what I'm telling that PyATS is one of the test environment Cisco test automation solution where you can go and run the test beds. So it has integration with Espresso, Ansible, RoboFrame, Jenkins, CI/CD pipelines. Then it has Genie libraries. They are providing good amount of parsers, Genie library framework, and then finally you have the core test infra. This is there to test the environment, test the use cases, right? And what I have done in our presentation also, I have created those notes that you will understand at least that what is the use of CML and PyATS. What we want to do, we want to run POC, troubleshooting, debugging, software development and testing, all those things you want to do. Maybe one slide is skipping here. That we can do from the PyATS. So you can see PyATS. PY stands for Python. A automated test system. Python automated test system is an open source Python based test framework developed by Cisco. It is used for automating network testing and validation. PyATS is highly extensible and integrated with the tools and other framework. So PyATS is something which is CLI based. See? CLI based Cisco test environment that can be integrated with CI/CD pipeline. You know that the logic of CI/CD, continuous integration, continuous deployment, development, right? So it can be integrated with CI/CD pipeline, but this is the CLI based tool that Cisco has developed. Requires knowledge of Python and scripting, highly extensible, integrated with many tools. You can go and integrate with many tools like you can see that Genie and Espresso and other tools. On other hand, CML, as name suggests, Cisco modeling language, it is based on Cisco devices. So that means the limited Cisco software supports are there, and PyATS can be integrated with any non-Cisco devices as well. So that's the limitation. The other thing here is this, that this is GUI based. Actually, it is easy to use. Better than we can go and use EVNG, because EVNG is multi-vendor support and it has GUI usage, and mostly nowadays people are using EVNG only. So you can go and test the network simulation lab environments. In CML, you have Cisco routers, switches, firewalls, Nexus switches, ASA firewall is there, and some Linux systems are there that you can go and simulate. But with PyATS, this is the test environment. You can go and simulate any type of device. Then I have added some more points like a scope, controller label, configuration management, scalability. So starting from here, CML, some points are there related to CML. This is very much GUI based, where you can go and test only Cisco devices, and people are using this for certification preparation as well. But again, I told you again and again, EVNG is something that people are using. Very less people they are using the CML for their certification practices and all. And Cisco is also providing test labs for CCNP and CCI, and they are using CML when they are providing those things to their customers or their students. Yes, you can go and integrate CI/CD pipeline to them. You can do network validation, performance monitoring. So either this is CML, Cisco modeling language, or it's PyATS. The core here is this, that you should have programming language knowledge, right? You should have a scripting or programming language Then only you can go and develop the code. Then only you can go and complete the use cases, because all the scenarios are different, all the use cases are different. One use case, maybe you can change few lines of code and use at the other use case, but you should know that how to change the code as well, some lines as well. But yeah, uh, all the devices, for example, I have to go and test the compliance report for 10 devices. In that 10 devices, I have two routers, two switches, two ASA firewall, etc. I can use PyATS, create the test bed, run the test scenario, and then it will tell you that how many passes, failures are there with this. Right? Now, again, this is the theoretical topic, but again, you want to explore more on PyATS, then you can go to developer.cisco.com, and then they will provide you the document, and then they can provide you some lab setup as well. You can see PyATS for network engineers, introduction of PyATS.
Rakesh, question.
Yeah,
This is popular, the PyATS, or the people use, or who
PyATS
why
is popular.
popular?
Yeah, it is popular because this can do many things. Cisco CML is not that popular, and multi-IOS test. So you can go and have a look. Let me open, but it will ask my username and password. At least I can show you that you have this developer.cisco account. You can go there, book a lab, and try it. I logged in via my Git account. Let me see. PyATS. Great. I'm not seeing that. Although I have this lab in some other place, but here it is not there. Maybe with my account, my DevNet account, this GitHub account, I'm not able to see that. I can see SDWAN, Meraki, and all those things, but I'm unable to see this PyATS. Sonic is there. This is also evolving operating system. This is open type of operating system. Sonic, you can do a lot many things with this. And then Cisco has introduced one more operating system, that is Open Nexus operating system, that you can go and do any type of automation, run bash shell, scripting, install packages, everything you can do with Cisco Open Nexus operating system. So those things are coming, they will come. Yeah, I think this one, Open NXOS programmability, although that was not coming PyATS, but if you have time, you can go and have a look to this Open programmability guide or something. 9,000 programmability guide and WebSocket, RFC cells and scripting. See how many scripting cells are there. Broadcom cell, Python API, scripting with Tickle. So if I go here, again it is going again inside to, what you can do, you can download the book and then you can check everything. If you are interested, you can go and see that how this open platform is working. Model driven programming is there. Now you will understand everything. XML management interfaces are there, telemetries are there or not. Anyways, uh, PyATS, we are there in the automated system. That lab is not there in this particular CCNA level. Cisco is expecting that we should know at least what is this, what's the use of this. Because when we'll go and develop a lab for this, that lab will be very big. And let me see if I have that lab file in our training session. Let me go and open this. Day number 5. No, it is not there actually. PyATS lab is not there. And if you want, I can show you a script for PyATS. Online notepad. Oh. So you can see I have a small sample for PyATS. PyATS, how it is working, show version, then the output, show IP interface brief, then it will check the output. Then any error is there. Then you have the test bed, what is the expected output, and then it will go and execute that command. It's just a small sample that you have your test bed, and according to that test bed, you are checking the output, and if it will pass and fail, it will tell you that. Right? For that, you need Genie as well. You need PyATS model to install. These are the packages, and then you can go and define the function, and then your test bed will run. Okay. A CML is nothing to do with all the test and all. It is just like a GNS3. So you have your devices in this lab. You can log in, and then again you need Python to do the scripting. Okay. All right. So let's move to the next topic. This topic, I'll cover the CI/CD pipeline. This is actually, I created one nice video and I have explained that, but for you, I will explain you because this is a small topic and I want to cover the CI/CD in one class. So leave this in upcoming days. I will go and create one complete 1 hour lecture for CI/CD. In that, I will cover this. Okay. So at the moment, just skip the CI/CD. We have session for CI/CD separately. We'll discuss about that. Then 5.5, what is the principle? Infrastructure as a code. Now, I want to do this infrastructure as a code, and that's why I'm preparing for my own CCI DevNet course. And you know that there are companies that they have achieved this target, that infrastructure as a code, and what they have achieved. Big companies like AT&T, your service providers, and big service providers. And nowadays, they are not writing the command to create some customer VRF or something, but they have developed some chatbot, they have developed some automation script, and suppose new customer will come. So what they need to do only, oh, who is the customer? What's the organization? What's the IP block? So they will get one website. In that website, they have to fill these things, and then submit. At the moment they are submitting, all the related routers, switches, link, uplink, US profile, everything will get configured. And it is happening now. people are doing these codes. Either it is in Python or Ansible or Terraform, doesn't matter. But this is there. The other big example we have related to this is cloud managed platforms. You know that AWS, Azure and all, they have their own SDK, software development kit. So when they are provisioning the infrastructure, they are not running those scripts manually and all. Everything is automated via Terraform, or they have their own cloud foundation formation scripts and all, right? So this is something infrastructure as a code that there are companies that they are using it partially or fully. It depends upon who is this director of the company, CEO of the company and all. If they are pushing for uh, this infra as a code project, then it is happening. Otherwise, there are other type of CEO or other type of directors, they don't want this. Logic behind this, that if you are doing everything via scripting, then who will go and manage the quality of a standard of the script, right? So if you are in a very secure environment such as banking environment or any type of government confidential departments and all, then on those department actually there are disconnect. On those department, you don't want that one department will go and communicate to other department, or within department itself you have some segmentation, right? So on those cases, the directors or the think tank, they are making the process difficult. So difficult in terms that they are making this process manual. So one process or one department will not go and interact with other department, and they are making these things slow, like manual. So manual effort is needed. So if something will go wrong, it will not spread, you know, within fraction of seconds or minutes. So those logics are there. I have seen businesses that they don't want any type of coding. They want a smart hands, and they are depending upon the human intelligence and all. And there are businesses that they want to reduce the manpower, and they want uh, accuracy, and all these operations or repeated tasks they are converting as a script and code and working. you know so balances are there. uh, at this point of time, there are smart network engineers. Smart means that they know automation and script and all, and when they are getting the task, they are using some sort of script and automation, and they are reducing their time. Like, suppose that task can be done in 10 hours, they can do within maybe 30 minutes or 15 minutes, 20 minutes, right? Or they can go and have a mix of scripts, like, they have two tasks, so they can go and automate one task, other task they can do manually, like that. you know you got my point, right? So there are debates that can we go for complete automation or partial automation, or some tasks we can automate, some not. uh, some tasks will not automate. But this is actually not that much easy for big organizations, because if it is a big organization, and suppose in that organization they have, for example, 50 network engineers. Now if 10 of the network engineers, they are doing the task via automation, and 40 of the engineers, they are not using automation, that is violation of code, right? Because as per the company policy, they should follow the same process. All 50 engineers, they should follow the same process to complete the task. So that means that someone is running the script that is not standardized, that is not approved by the system. Otherwise, everyone has to go and use the same sort of a script or the methodology, right? So there may be, in production environment, there may be full automation or no automation. There is no point of doing something partially and doing something manually among the team. Either they will follow the same process or they do not follow the process, because there is a risk involved in this. Okay. uh, so then infrastructure as a code, I told you that everything you can go and automate everything within the network. So for that you can use version controls. For that we have the githubs and other tools. Then you have declarative versus imperative. That means you have the Terraform, AWS cloud formation, and imperative we have the Ansible and Ceph. This Terraform is actually picking up, and AWS cloud formation is picking up. With Terraform you can automate not only the cloud infrastructure, you can automate ACI, and you can automate NSX, VMware NSX-T. It is very much capable language and it's easy as well. And then you can see the idempotency and Terraform Ansible. Basically, people are using Terraform Ansible, and for small things, people are using Python. Small things like running scripts, patching, and all those things. Then automation, we can go and use Jenkins, Ansible, Terraforms. Testing, we can go and use test infra, Terrafest. Like these are the tools, right? There is no one program or one tool that will provide you infrastructure as a code. So you want to have your version control repository, you can go and use some tool. You want to use some language, you can go and use Terraform, Ansible. You want to automate the system, you can go and use Jenkins, that promotes full automation and provisioning, configuration, reducing manual efforts. And Terra, for testing environment, you can go and use test infra and etc. Then for
A ques-
consistency, again, Terraform, auto scaling, and all those things. Yep.
Question. From Terraform and Ansible, which is more easy to learn or more easy to use? And also we need to pay licenses for this one because in Ansible for Red Hat,
Yeah.
look like it's something free, but it's not everything free, no?
Both are licensed. Yeah.
Both are licenses.
This also. And that's why, means, like this is complete infra as a code. Do not go for that. It's actually not required. For normal network operation, Python is more than enough.
To
We
start
can
for
do
us, we
everything
can
with
start
from
with
Python.
Python.
Yes, with Python you can do everything in Nexus operating system that is already there in
Mm.
that shell. The guest shell is there, Python is
Mm.
there, and you can do whatever you want to do. It's
Yeah,
more than
because
enough.
our cloud architect, oh, they told me, oh, I will use Terraform to use this one. And I don't know how to use it, but the guy tells that, oh, I'm using
Yeah,
Terraform and I'm sure. But
Terraform they are using because from Terraform not only they can automate the networking components, but it can automate the server deployments, auto scaling, other security feature. It can
mhm.
do all sort of things. And this is very similar like cloud formation. Both are very similar, Terraform and this.
But to start using, I need to buy license or why can use some
Yeah,
free or
I don't think so
you don't
that it,
know?
yeah, means freely obviously you can use. I have this in my lab as well. Freely we can use it. No problem on that. But yeah,
Mm.
this is some licensed, some cost is there. But yeah, we can use it freely as well. And you
Because
can,
Ansible is some version free, but you can do the very
yeah,
limited, no?
yeah. If you go for Ansible Tower and others, then you have to pay.
Okay.
Yeah. But with these clouds, they have their own language like cloud formation and all, which is coming with that
Mhm.
cloud package. So that can be used. Terraform is also not that expensive, I think. Yeah, because they are developing the modules. Because if you see the program for Terraform, this is one liner, two liner. Because behind the scene, their init and build, they are happening. So you are importing some packages, and those packages, someone has to maintain that. So that's why I think they are charging something. But I can check the prices. I can come back with this. Hasi Corp. is using that HashiCorp Terraform. That the product. Again, you can check online as well, like how much
Yeah, we'll
cost
take
and
a look.
all
We'll take
those
a look.
things. Yep. All right. So these are the philosophy, like, when you want to do infra as a code, so you don't need only one programming language, but you want to, you can see complete IT infra. And in IT infra, we don't have only networking things, we have compute, storage, all those things, and then you have servers. Everything can be worked. So entire IT infra can work as a code, means that you can create the automation for the IT infrastructure, but you have to take care of all these things. That your choice of programming language, choice of testing environment, choice of cloud as well, because some servers are hosted in cloud. So all those things you can go and use it and it will work, right? Then I have created one supported document like Terraform, declarative tool that supports multiple cloud providers, AWS Cloud Formation, Ansible is Puppet and Safe is there, right? I have listed only these, means these are the top thing. If we are going for um, IT infrastructure as a code, but we are not limited to run the operational task, test the operational task, and all those things, because I told you earlier that we have the capability of API that can be integrated with any type of post, any type of method, and that those methods you can go and automate via the Python. Python can do lot many things, lot many things we can do with the Python. Python people are using for machine learning, people are using for AIs. It's a big, robust language. And as, as per the networking requirement, everything we can achieve with this API. The method means maybe NetConf, RESTconf, etc., etc., and then the Python. So you can achieve everything because the vendors, the OEMs, they are providing good hardware that can understand all sort of APIs. So if that device is able to understand API call, you can do most of the things, right? Again, you can see that describe the capabilities. This is also very much theory. So let's make this last topic for today. Describe the capabilities of automation tools such as Ansible, Terraform, Cisco NSO. Cisco NSO is using the modeling language. So first of all, in 5.5, they have given one topic that move from your normal operation to infrastructure as a code. If you want to move, you need these things. And then it is narrowed down to Ansible and Terraform. Ansible is there for configuration management, application deployment, orchestration. This is it has agentless architecture. It is extensible, and idempotency means that ensure that the repeated execution of playbook result in the same system. Means different type of, I think, input can go and give same type of result or output. That is idempotency. So these features we are looking from one programming language, and Ansible is a fit for that. It's easy to use and it is extensible. It is actually popular as well. So you can do configuration management, application deployment, orchestration, agentless, extensibility, and it is idempotency that ensure repeated execution of playbook result in same system state. Like whenever you're running the program, it is giving you the same output. It will not give you different output for different runs. That is one of the expectation with these programs. Now, Terraform is something like a game changer for this cloud deployments and all, and it is one of the language supporting infra as a code. It is using the declarative approach. It has a states actually, and it's actually very easy to run. Only 2 3 commands are there that you can go and execute, and you can get the result. It is supporting multi-cloud dependency management. Everything is built automatically actually behind the scene. The development team is taking care of all those state management and everything. So state management, yes, it has to go and manage the states while you are running this Terraform. It has different states that it will go on and give you the output. It is modular. It's actually very easy to use. Terraform. There are so many examples. I will show you one example related to Terraform. Extensible plan and apply. It's very easy. You can run and it will work. Infra, multi-cloud support, dependency, and all those things are there. And then finally, in this list, we have NSO, which is following the Yang type of modeling language. It is multi-vendor support. And with NSO, you can go and manage within Cisco system, you can go and manage different type of devices such as Juniper, Palo Altos, and all those things. So it has multi-vendor support, and it is one of the Cisco popular product that customers they are using it. So here you can see the summary, service orchestration. It is model driven. It is using Yang model. It has multi-vendor support. So it is not only supporting Cisco, but you can automate, orchestrate different type of vendor devices as well. It will do configuration management. It has integrity, extensibility, real-time network management. It is used for those type of use cases. Okay, I'll not go beyond this. I want to show you something related to Terraform. And if you have your lab environment, you can test that. Let me go here and GitHub ACI. Actually, let's go to this GitHub first. And ACI Terraform. Plenty of examples are there related to ACI. See, this is the format. So this source I was telling about. So if you go and run this in your environment, but you should have this source maintained. Suppose if Cisco is maintaining this source, then there is no problem. You can see username, password, and this how you can log in. In my case, generally I have different type of files to manage it. Now what we want to do, you want to create a tenant. See how small this program is. I want to create one tenant and application profile, right? So within that tenant, I want to create application profile, and this is small script. These are the variables like, oops, you can have some other file to maintain these things. And then you have the task, right? So create a tenant, and in that tenant, create application profile. In that, if you want to create the bridge domain, and in that you want to have the subnets and all those things you can have. It's very easy. You can have a look on this. If I go to examples, 49 minutes ago, so someone is working on this. And domain, access group, ACI, NE, BFT, CDP, cloud account, EPG to static bus. There's a .tf. Let me open this. See. So see, this is the format, but you have your variables somewhere. What you want to do, that you have your tenant. This tenant is created by Terraform. So creating the tenant, creating the application profile, then we have the EPG, then assigning the port to the EPG like a static binding with some VLANs, the interface, these things that we are doing manually, that you can. So what it is telling, that creating one tenant, within that tenant create one application profile, within that you can go and have one EPG, endpoint groups, and that EPG you can go and do the static binding to different interfaces, right? So that's the code. Now if you see the code, you will see this is very much like what we want to do. It's very easy to understand these terraforms, and it is heavily used within the ACI, NSX, and this cloud infra. People are using it. Okay. If you have
Yes,
any,
question. Is any graphical interface for this Terraform, or everything is scripting too?
thanks for joining. Day number 18, we have lot many topics to cover today. We are going to learn about the workflow to automate different type of networking, orchestration, networking management platforms. Then we have to interpret the result, and we have to check that within the diagram as well, like how we can go and interpret these things within the sequence diagram. These topics are, that these topics are as per CCNA label, like network associate label, that you should know the fundamentals, basics and all. If you see something, you can understand what is happening behind this script and all, and behind the scene how this REST-conf calls are working. So those flow chart, you should understand while seeing these scripts. So let's start with 5.7. Let's move. You can see that interpret sequence diagram that includes API call. So what I have done actually, I started from what, that's why you can see this arrow. In this document, you'll start. First, I'll cover this one because this is the easiest thing to cover. Then this one, and then finally this section 5.7, because here I have to show some lab as well. So like that, I have started from bottom to top. So let's start with easy topic, that is interpret the sequence diagram. If you see the sequence diagram, there are some terms will be used, like who is the actors or participants, the lifelines, activation bar, message and arrow. So what I have done, I have one diagram. You can see this is the diagram, and this diagram is not filled that which section what is happening. So for that you have the explanation. You can see this diagram. In this diagram you will see that you have these message boxes, then you can see this bars are there, then you can see the arrows are there, then you can see that dotted lines arrows are there, right? So all these things, this is the standard diagram, and that is for designing sequence diagram API orchestration. If you go to the slide, you will see that identify the participants and the lifelines. Look at the top of the diagram to see different participants involved. Each participants will have a lifeline running vertically down the page. So participants are there and they have the lifeline. They have the lifeline means, oops, they have the lifeline means that suppose they are sending some query and they are gone. But in this diagram, you can see that this lifeline is more than this lifeline, then this lifeline. Like that, you can see that this is very simple example, but you may have so many participants and their lifeline. You are asking something? Okay. Then understand the flow of message. Message API calls are shown and the arrows from the lifeline to other lifeline. The direction of arrows indicate the direction of the message of the API call. Read the labels on the arrows to understand the type of API. So here you can see that this is the arrow that is going from one actor or participant to other participant In other words, you can say that that arrow, that we have the arrow, let me go here. The arrow that we have, that is the API calls, maybe put, get, post, delete, etc. That is going from one lifeline to another, means one participant to another, and then the direction indicates that the API call from one actor to other actor, one actor to other. So this is the arrow. It will go, it will fulfill something, and then it's up to this, that how it will respond. So you can see that some query is going there, and again some query is going there. Then you can see the response which is hidden here. This response can directly reach to first actor, or you have intermediate response, first this and then this. So that's why. Then sequence of interaction. The sequence of messages from top to bottom shows the order in which the interaction occurs. Follow the arrow from the top down to understand the flow of the operation. So this is your lifespan, right? Within this lifespan, it is going to one actor or participant to other participant, and then this is the lifespan, means that you are sending some, for example, AAA authentication request, and finally you are getting the authentication reply from the AAA server. This is a user which is connected with switch, and then it is, and this is some net intermediate to networking devices. So suppose this is the supplicant, this is the network devices, or sometimes we referred as a NAD, network access devices, and this is a AAA server. So this is something like intermediate device. This is the final server, and this is the request, or the request user or requested user. So you can see request will go here, and then it will, you will get the response. This is the flow chart. In this flow chart, if you have any query, please ask. If no query, then we can move. And very much self-explanatory. You can go and read these type of message: activation, return message. That's it. You can see a request, forward, a response, client to server. In between, you have some gateways. Right? Easy, straightforward. Then I explain what is participant, flow of message, type of messages, right? The activation, and then finally the summary. Okay, so you will understand, mostly you have to understand this diagram, and you have to understand this diagram. Okay, let's move on to the next section, that is 5.10, where we have to interpret a result of a RESTConf or NETCONF query. Now today I may show you this in the lab as well. Today we have an Ansible lab related to Nexus devices or data center devices. We can check that, no problem on that. We know that we have RESTConf and NETCONF. What is the difference in between these two? Anyone can tell the difference? You know the difference in between these? RESTConf and NETCONF. Tell me the difference. Luis?
It should be the NetConf is the client to server, right? And the
NETCONF
RESTConf
is...
is
Mhm.
and the RESTConf is the one you use to HTTP.
RESTConf is both can be work as a both can take the request as a API calls, right? But there are some minor difference in between RESTconf and NetConf. What are those minor differences? You can see here as well. RESTconf uses HTTP based method to interact with network, and it can, so as a data encoder, it can understand both JSON and XML. This is one very interesting aspect we have, but you know that NetConf is understanding only XML format, right? So in this example, you will see that I have one query. You're able to, you know this thing, right? This is very important. That's why I'm highlighting all the time. RESTconf can understand both. NetConf understanding only XML format, and NetConf is using port number 830. We know that this port has been used within the Cisco DNA, within the Cisco SD-WAN, Cisco SD-WAN DNA, Cisco devices. They are using NetConf within the system itself. But yeah, we can go and do the API configuration with help of RESTconf. But within vManage, to manage the devices, they are using NetConf. Within Cisco DNA, to manage the telemetries and all those things, they are using NetConf port number 830. The use cases are there, right? Okay. So here you can see the example API query. This is one of the API starting from a RESTconf data interfaces and then interfaces. Interface equal to gigabit Ethernet. Now you need some sort of header information as well. So I want to use application Yang data model. Data is JSON. And basic authentication, username, password for authorization. Then you can see the result. It is telling that uplink is this is connected to router, etc., etc. This is the output. This output is very much in Yang model, and this is the JSON output. JSON format, data modeling output, right? This is one of the example related to RESTconf query. We are doing the query and we are getting the response, right? Then I have explained little bit of explanation related to this result that we are getting. So this result is very much like leaf. So you know that this how this Yang is Yang model is. They have something like containers, leaf and containers, leaf, and then you have some output container, and in between that you have some result. For example, IPv4 address. Within IPv4 address, you have these information. The status of interface, Boolean true, that means it is up. Then the interface name, that is a string. Then the description is type string, type is string, and then the status is Boolean, like true or false. Like that, we have seen this in our previous session, that how this Yang model look like. This is the query result. This is the RESTconf query result in Yang format. Data encoder is JSON. Data modeling is Yang. Data modeling, data encoder, RESTconf. You can see now everything is connected. So RESTconf is connected with modeling language, and the output is in JSON format. Right. Then this is the explanation about the output, containers, and all those things. Actually, we have discussed this thing earlier. The NetConf query. I told you earlier that NetConf uses what? XML for data encoding, right? And communicates over SSH using port number 830. So that's the difference. The first line is very important, and it may be one interview question, that what's the baseline difference between the RESTconf and NetConf. RESTconf can understand both the data formats using HTTP method. NetConf is using XML as a data encoder, communicates over. SSH, see, the communication channel is SSH. What is the communication channel here? HTTP method. That means it may use port number 80 or 443, right? Because HTTP or HTTPS, you know that port number is 80 and 443. They are using application port numbers. But here they are using SSH, but port number is 830. This is not normal SSH port 22. All right. Then again, query, XML query. This is the XML format. You know that if you do the query, then you will get the result in XML format. This also we know, and this is actually a little bit difficult to read in longer run if you have such type of output. So you can see the output here, XML reply here, and you can see the JSON reply. This is the JSON reply, and here you can see the XML reply or response, and you can understand that which format is easier to understand, right? Any doubts so far? Please feel free to ask. If you have any question, please ask. And meanwhile, let me try to open my server for the lab. Automation. Okay. Try to connect. You can connect. Okay. All right. So next topic we have, you can see that we want to identify the workflow for automation, different type of networking orchestration management platform. For example, ACI. ACI, you have different tasks. If you know the construct of API, if you know the construct of ACI, in ACI you have two things. You have something called physical infrastructure, and then you have something called logical infrastructure. Physical infrastructure is nothing but your underlay, and on top of that physical infrastructure, when you are doing configuration, logical configuration, that is nothing but your overlay. So underlay means that how you are going, how you will go and connect your leaf and a spine and your epic controllers and all those connectivity. So physical connectivity, all the spine connected with leaf, leaf with a spine, like that. You have some cloth fabric. But once you have that fabric connected, right? Once you have that connectivity, then how you can go and manage different type of applications or different type of customers, business applications on that. So for that you need some logical construct. Those logical constructs are nothing but the tenants, application profile, endpoint groups, VLAN, VRF, bridge domain. All these things are logical entities that you can go and use some API. You can create, update, delete, etc., etc. Right? There are APIs for monitoring and analytic as well. There are APIs to configure the policy management as well. You can see one example here. This is a big example where we are using some sort of RESTful API. Why? Because we are using request format here. You can see get the token. I'll not go in detail. We'll check in the lab. So you can see that get the token and the create. Get token means it will go and use some sort of get method, right? So response, oh, get token also we are using some post method. I'll come back to this. Then creating the tenant, then the calling that function. So the function that we are defining here, we are calling here. So it will go and create a tenant, name new tenant, right? This is the example related to how we can go and use the REST API to configure something, right? Use some post method. I'll go in detail on this, don't worry, once I open the lab. Then Meraki also I have one example. You can book the lab in the Cisco DevNet, and you can do that. Create VLAN within the Meraki system, how this post script is working. That you can see. Then DNA Center API. From DNAC, I have lot many scripts related to DNAC, and few of them we have checked earlier as well, getting the device list and all. Then if you have some template, you want to apply template, like you have some configuration and you want to push to n number of devices, you can do this with template. I created one video for template as well, how to use it. But yeah, this is the format, you can go and use it. Okay, so in lab, I told you that we are going to perform one lab related to Ansible, right? Ansible, they are using playbooks to manage the configuration. Why it is useful? Because not only the networking devices, but the servers, the other IT infrastructure devices also you can go and manage via the Ansible. So that's why it's a useful tool. What I have done that as per the syllabus, in the syllabus they have mentioned this headline: identify the workflow being automated by an Ansible playbook, management package, user management, basic service configuration, start stop. So that's why I created these 4 points: management packages, user management related services, basic configuration, start stop services. And then I have shown this related to few of the applications like HTTP daemon, next generation servers, old software if you want to delete or rename, update the NGINX, install the HTTP daemon. Like that, I have shown one example here that whenever you are starting the Ansible script, it will start with dot 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 like dash 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 3 dash, then defining the name, host. I'm going to show you this lab in networking over networking devices. Don't worry about that. So you can see that host and this, then you are defining the task. Within task, you have 3 tasks. Ensure that package is installed, HTTP daemon, then ensure that you are updating the NGINX and you're removing the old packets. And that's it. See how easy the format of program is, how easy this is. This is very much like we are writing the use cases. And then if you have to go and run the playbook, so you can go and run the playbook, package management and everything I have shown here. I'll not go to this. So these are the example like playbook example related start stop services. But in the first, okay, start stop services, if you have started, stopped, restarted, these state you have to go and use. If you have something related to playbook basic service configuration, basic service means NTP or SNMP or blah blah, those services. So services here, SSH, NTP, firewall rules, so are enabling like this. And the user management, so what user, what device access or what privileges they have, those things also you can do via the Ansible, right? So let's go here, let's see what is there in our lab. I have one lab setup where I have some Nexus devices, 2-3 Nexus devices, they are connected to each other. If I log into this, let me try to log into a few of them if I can. Seems
Ratnesh, these Ansible are libraries, no? Or what is that? And Ansible, some call it, and
Ansible
in the
uh,
previous screen you show
libraries
something.
only. Yes, you're right. You can install as a package, as a software, right? As a software, you can install this Ansible. So in this already it is installed, and then you can go and use it. Like you're installing this Python, right? Likewise, you can go and install the Ansible. There's no problem. It's easy. In this server name itself is like um, Ansible. We can go and say version. You can see that Ansible 240, and the package within Ansible, we are going to use some Python package. This is the location. Python we are using, some old Python we are using. This is little bit older lab. Nowadays we have Python 3.11, 3.12. When I go and run these playbooks, you will see that how I'll go and run this playbooks. Inventory and JSON format. So you will understand that how we are using this. When we are running the playbook, I will show you the playbook example. Say Ansible playbook, and I need some playbook here. Actually, that's for example ABC dot in YAML format, and then I can go and check that. Let me show you that. Let's go to DC. First, I'll go to Nexus operating system. And we have CLI and REST. I am interested in the RESTful, but I will show you the CLI as well. So there is one Python script, first of all. Obviously, we'll use Python to run this. What this will do, this Python script will do, that it will connect to the host. We have some Nexus switches. Over those Nexus switches, it will go and enable one feature called feature NX API. So we can go and run the API calls to the Nexus devices, right? So let me go and run this Python, and that is, what's the program name? Enable the feature. You can see the host here, that is logging to Nexus and enabling the feature NX API, right? Feature NX API. So I can go and run the API calls. We have the NX OS. If I can SSH, NX OS, or maybe like this, SSH -L Ansible, the username, NX OS, that's the name of the host, OS V1. Try to log in. Yes, Sybil. Show IP interface brief. Show run interface management. Just wanted to see what is the management IP. So it has management IP 198.181.51. So if I can go here and go to the properties, rename, how I can go and change this. Anyways, I can go here and connect. Oops, not like this. I can go here, click this. Username and NX OS. Close this. Let me close this. Let me close this. Okay, so we have one automation server and we have one Nexus switch where we want to run the lab and all those things. So let me go and exit from here. Can I do clear? Okay, and now we are where? We are in the lab, and here I want to go to rest. Now we can see the Python script to enable the features. This is the Python script. This is little bit lengthier. Uh, and this is little bit older format as well. This is using Python 2.7, but you know that we can convert this to 3 or any format. There's no problem on that. So again, this is doing the same thing, that logging to the device, making sure that we are logging to the device, and then enabling the interface VLAN feature. So if I am here and see show features, right? Feature and section enable or grep or include enable, something like that. Enable, right? So you can see that we have only NX API enable, you have the telnet services enable. Now if you go here and run this script, a script name, and you can see getting to interface VLAN successfully enabled. So now you can see that this feature got enabled, right? Now the use of Ansible. I told you that use of Ansible is also there. So in this, there are actually lab 1, lab 2, lab 3, and lab, oh, let me see where we are. Oh, cd dot lab number, lab number 2. What is this here? Oh, let me see. Okay, now you can see that I'm going to show you one example related to Ansible. So let me show you that first. Create VLANs and then external variables. So this is one of the example. Let me show you another format so you can see this. Okay, little bit better to read in VI editor. So starting with dash 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 name, create the VLAN playbook. Host is one file, one inventory we have for host, where we have one host NX OS v1. Gather fact node, no, like this is the way we are writing starting the program. Then we can define variables within the program itself, or we can call the variable from outside. So this VLAN 20 we are defining here. I have VLAN 20 whose ID is 20, name is app, and then I have external variable whose VLAN is 30, maybe database or something. We'll check that. So we can call the variable from outside of this program as well. So this is the starting, this is the variable definition, then task. What I want to do, I want to create VLAN 10, right? So if I want to create VLAN 10 within the task itself, I can create local. See, this is the global variable and this is the local variable. Within the task, we are creating something like this is not a variable actually, but within the task itself, we are putting the parameters value and creating it. Then for VLAN 20, we are calling from here. This VLAN 20, you can see that VLAN ID, VLAN dot ID. So this ID will be 20, VLAN 20 dot name, name is app. So we are calling from here on the top, from here. But for VLAN 30, we are calling this from the outside, like this will be external variable. It will come from this file, right? So within the task, outside from the task and coming from outside of the program, we have these variables that we can go and create. So let me go and quit from here. Let's see this Nexus. Show VLAN. You can see we have only one VLAN, right? With the program, we'll go and create the VLAN. So here you can see the inventory. Let me show you what is there in inventory. We have the NXOS in inventory. Likewise, we have 10 or 100 of devices in the inventory. One by one, the script will go and log into those devices and run the playbook, right? Then you know about this external variable. Let me show you that one more time. So external variable YAML file we have, create variable YAML file we have. So why not we can go and run the Ansible playbook with the create. And if you want to check this, you can check this as well.
Rakesh, question. Basically, what Ansible is doing is executing the programs only or what?
Running
The
the
scripts?
script, yeah, running the script like we are doing via Python. Ansible will do the same thing for networking devices, but it has some broader scope and it is agentless. It has some own features, like it's easy to use, and the maintainer for Ansible, they are creating different modules for different operating systems, so you don't have to define everything in a program. You can call those packages and it will work. Like when we are using Python script, so Python script, you have to go and give some statement like import request, import this, import pandas, import etc etc. In Ansible, they are managing these modules and they can be connected. So here we are not defining anything. In these playbooks, we are not defining anything because maintenance of these things are there. So maintenance of Nexus operating system. If I go to their website, they will tell, oh, with Nexus operating system, we are supporting operating system 9.0, 6.0, 7.0, these modules. And those modules we can automate. But in Python, we are doing everything. We have different style of scripting, interacting with devices and getting the result. Okay. Data center, basically people are using Ansible because of some more features that Ansible has. And for normal troubleshooting and automation, people can use Python. Python is a programming language that programmers can create their own things. Ansible, what you will create in this? This is some format, you are following it. You know, you have some script and you can follow it. Python, you can do some innovation like that. Okay, and again, you can see that this has been replaced via the Terraform. Like in terms, like people are using more and more Terraform than using Ansible. Ansible had its own use cases. Terraform has its own use cases, right? So now why not let's go and run the Ansible playbook and create VLANs and the I for inventory against the inventory. So now what this is doing, that VLAN creation playbook task, ensure VLAN 10 exists. If it is not existing, then it will go and create that. Like that, it will go and check task 1, task 2, task 3 one by one. Okay, this is older version. It is telling that it is not available, but yeah, you can see here the output. NXOS 3 task, okay, change 3, unchanged 0 failed. So now if you go back here and if you see the VLANs, we'll create web app DB, no problem, right? And these things you can do via the Python as well. But again, the point here is the standardization. You have one standard server that some team is maintaining their packages, their OS, their version, and all those things. And from that server, as per the request, some change is happening. As per the request, someone is running those scripts to create something, right? Okay, let's move on, and I have to show you one more thing. I can share all these script if you want, but these are older script. You have to convert this in the latest one. And then I can go to ACI, Ansible. Let's create the tenant YAML, and first let me show you the inventory and the see the playbook. How small this is, right? And earlier I have shown you one example. Let me show you the differences here. One example that is related to ACI, creating a tenant. See the Python versus Ansible. This is Ansible. I am creating one tenant, ACI lab, test tenant, and this is Python, which is easy. Obviously, you will tell that why not do everything via the Ansible? It's very structured and it's easy to use. If you create Ansible towers and feed everything, then managing operations, creating new tasks, it will be easier from here. Here you need innovations, knowing that you're getting the running the API, getting the response, then doing this, filtering it, and putting that response to other functions, filling it, putting it, know the structure and all those things, and then finally call it. But this is like programmer friendly, right? Programmers, I love this. I like to do like this only because I will quote something and others will not understand. Right? But here is very much like everyone can understand what they want to do. Right, Luis? You will program something and when you show the code, oh my God, they'll say, oh my God, what you have created. But if you show this Ansible script, oh, it's very easy. Since Ansible is easy, what is there? Host name, username, password, tenant what you want to create. And that's it. Wow.
Yep, that's true. And what happened if, for example, in this task that you're sending, the device is requesting for confirmation, like is it is waiting for a response. Like let's say like it is asking like, are you sure you want to create this tenant? Yes, no. How do you deal with that type of request?
We can do that. Like we can add this user interaction in the script that it will ask that you want to proceed for next step, and multiple ways that programmers can do. In Python, sometimes I'm giving this user input, press enter. So in the screen, it will ask you, you want to go next, press enter. You want to go next, press enter, like that. Or
Yep.
maybe some pop-up message will come. Are you sure? Click, and then pop-up message will go, and then you can go next. Anything we can do. Like it's like whatever we can think, we can program. It's like that. Right?
Okay.
Let me do one thing. Let me quickly open the ACI. So if we go and run this script, it will go and create one tenant. So let me open that. That is there, but maybe the font size is very small. Let me try this. You can see that. Okay. Epic. It's very old Epic, like 1.2 or something. But it was very good. User ID, username. Oh, okay. I can go to tenants. You can see by default there are 3 common infra management, right? And we'll create our own vi own tenant yml YAML file, right? Then once you are in vi editor, first thing you have to press enter. Then it will come to insert mode. Right, good. Let's see. So if I clear this and you can see name, playbook for testing, user configuration, epic, local, everything is same. Then prompt, proceed. Do you want to proceed? Yes, no. Message, choose, proceed, right? So I have added some user interaction and let's try to run this. Siebel playbook own tenant with inventory. See, it's asking, right? Do you want to proceed adding new tenant? And even this tenant name that we have, we can make that as a variable as well. Like here it is ACI lab. You can see the tenant here, tenant, it will create ACI lab. This also we can make as a variable, like because this is script is generic. I want to create new tenant and all those things. So now you can see that message user choose yes is correct the spelling for that, and this okay change unchanged. All right, let's go back here to the ACI. Refresh this. See ACI lab got created by a script and with user interaction, right? We have put that user interaction to variable as a prompt, and then in task also we have put that message. In this it is telling that user has chosen this option to proceed, and like that it is working. If I put no here, for example, then you can see the output. Right.
Yep.
So in the debug you can see that fail. Why? User choose not to proceed. Like that, this Ansible script, you can work on that on YML. I can go and insert this. I can do this. Skip. Oops, something is wrong. Okay. Uh, so this, if you see the tenant, I just wanted to make this tenant as a variable. So for variable, you have to use this and procedures. So if we go here and Ansible playbook and then own tenant inventory, let's see, proceed, you want to proceed, yes. Enter the name of tenant you want to create. My own tenant today. And now if you go here, let's see, it's got created. So now in this format, you can see that we have added the user interactions plus uh, user made tenant name. Like while you run the script, you can create what type of tenant you want to create. Like that, we can develop the script. We can add more and more. Like in this tenant, if I want to associate VRF, we want to do this, EPG, EP, whatever, can do this. Right. So that was this.
Question the Ranesh. In
Yeah.
most of the scripts,
Um. I just paused the recording. Could you please repeat your question so I can record your question and then I'll answer?
yes. So the question is that this script we see a lot of passwords that are typed there, and per security is not better like to better ask or prompt for that information, so the user input that manually that information.
Okay. For example, hide password. Yes, so we have multiple options there. What we can do that we can call the password from some other file. That is one thing. So someone can't see while we are executing it. Some soldier surfing is there. Someone can see the user and password. Or we can hide the password. We can make this password as a user input. Right. So when you run the script, it will ask what's the username, what's the password, and then it will proceed. So that thing also we can do. Right. So for example, let's go here. Try to make this as a variable. So anyone can go and
Yeah, it's look safer. Yeah.
you can see here, enter the username
Yeah.
and password. So now if you see this program, you can see that do you want to proceed? Username. What's the username? What's the password? The name of tenant. These are the variables now. Then in the program itself, the username is a password tenant. All these are variables. And then proceed. So now if you want to Ansible playbook and then what is that
I pass.
inventory, right? When you run this program, proceed, username, for example, is password is maybe correct password. Want to create with password, and then if you come here, you can see it. So
Okay.
yeah, anything we can do with the scripting, no problem.